First of all, for those who don't know me, I've been in the Kubernetes space pretty much since pre-version 1.0. My background was in networking. I was one of the founders of Project Calico, which is one of the most commonly used networking plugins for Kubernetes, and then was part of the team that set up Tigera, which was the company founded to go commercialize Project Calico. So after a couple of decades in Silicon Valley, with all of the excitement and pressure that you get in Silicon Valley, I decided to move back to Europe this summer. And so I've been at Kinvolk since KubeCon Barcelona. So that was my first week there. So it's actually really exciting to be here and see all of this excitement around Kubernetes and around cloud native here in Europe, because sometimes, I mean, I know I was there for 20 years. You live in Silicon Valley in a bubble and you think that you're the center of the universe. And actually, I think with the way the internet has opened up communication, the way these kind of events are videoed and shared, you know, it becomes more than just the people in the room. Anyone, anywhere in the world can use these technologies, and that for me actually is one of the really exciting things. And so I was really pleased to see the sponsorship that's being funded out of this conference going to development of cloud native technologies in Africa. I think these are things that are really huge impacts that we're having with technology. So again, it's just a lot of fun to be here in Europe and share today with you all. So how many of you have actually already started adopting Kubernetes? And show of hands, okay. For how many of you did that start with a conversation with a boss that went something like this? So yeah, we need to get ourselves some Kubernetes. Something like that? No. So I think that this is certainly for people that I've spoken with. It's there's a lot of interest in Kubernetes, but people don't necessarily know where to start. And you go type in Kubernetes into Google. A lot of people will start off. And certainly a while back, the standard way for getting into Kubernetes was you go and look at Kelsey Hightower's Kubernetes the Hard Way. And as you can see, there's a lot of steps to go through just to get a cluster up and running. It takes you a long time to get your head around it, but you get there and boy, do you feel good. When you first get kubectl, you type that in and it responds, it's alive, you've built something. And this is something you feel really good about. And there's a name for that feeling, and it's the IKEA effect. So when you've put in blood, sweat, and tears to build this thing, it doesn't matter how ugly it is, you feel a sense of ownership and pride in having created it. And I don't claim to be the person that noticed this. This was actually something I noticed on Twitter the other day. This is a great description of Kubernetes. So for a lot of people, this is how they get into Kubernetes and understanding what's going on under the hood. It's a great way of doing that. But then once that cluster's up and running, you start to think about what does it take to get it into production. You'll start to read around all these blogs and you'll think about, well, how do I get traffic load balanced in? How do I do networking? So there's actually a lot of different options there. Oh my God, how do I secure it? I'm reading all of these blogs about how various companies got hacked, and I'm not going to mention the names, but we all know lots of them are out there. Now, how am I going to scale it? I've created this cluster with 3 nodes. That's awesome. How do I get 4? And how do I make that happen automatically when I start to when it needs to? And all of these other areas, and people are talking about service mesh, and now I've built this, how do I automate this? I want to create 2nd, 3rd, 4th cluster. How do I make it all the same and repeatable in a way that I can actually operationalize? So a whole load of concerns that you have to think about. And absolutely, it's a lot of fun to go solve these problems one by one, but that may not be necessarily the best use of your company's time. So this isn't a new problem. This has been around since early days of Kubernetes. It just gets worse because there's more and more projects that get added in and more things you can do. But there used to be a really simple decision tree here. Do you want to do all this stuff yourself? Well, yes, you're welcome to. There's upstream projects, upstream Kubernetes. Go do it, have at it, and have fun. If you don't, well, do you actually want to manage it yourself? If you do, you can go get a distribution. And in the early days, there weren't that many. It was probably a choice between CoreOS and Red Hat fortunately simplified that choice for us. And if you didn't, then there was probably Google Kubernetes Engine, GKE, for obvious reasons, was really the first viable option out there, and that was probably what you went with. But then a whole lot more of flourishing happened in the ecosystem, and this is a great thing, right? A lot of people building their own versions, their own distributions, a lot more managed services coming out, whole lot of options, and great. They're all certified, so you can choose any one of these you like. This is just straight off of the certified Kubernetes page. All of these distros, and this is probably not even half of what's out there. There's probably 300,000 more jellyfish out there that we don't even know about. So how do you get your head around categorizing and thinking about where these different distros are coming from? And I want to just share with you a way I've been thinking about it, and it may help when you think about a particular distro, to think about what kind of problems is it trying to solve, and then map that to what you're trying to solve. And this is your classic 2x2 matrix. So I think the first thing is on that x-axis, to think about going from something that's very DIY, the kind of build it yourself, Kubernetes the hard way, evolving all the way to a fully managed experience where you don't have to know anything about Kubernetes. As you worry about it as much as you worry about managing disks when you're using S3, right? It's just below the cover, and it's a service that's provided for you. And in between those, you can have something that's packaged, so it's a distro you get, open source, probably downloadable, not supported, but someone's done the thought of picking an opinionated set of projects to include. Or it could be supported by a commercial vendor, so you're having them come in and help you get up and running. But these are kind of all on a continuum between how much you want to do yourself versus how much you want to offload. And then on the vertical axis, you can think about whether a distribution is targeted or a solution is targeted at a specific cloud environment, maybe a single cluster, all the way up to running and managing multiple clusters on multiple clouds. There's a lot of different dimensions you could potentially apply, but I think for me this is probably the biggest one, and the one where we're seeing the most evolution in terms of distributions. I know it's been a big thing with OpenShift 4. It's been a big thing with a lot of other distributions as well. So one of the things that I think we can see here is you can start to put these on this map. So you can think about something like COPS, or KOPS. So for those who don't know, it's a great little tool for deploying on AWS, basically. There's people been working on that, on maybe trying to take it to other platforms, but basically it's an AWS single cloud kind of solution. Does the job well, it's packaged, no one's going to give you paid support on it, but if you're trying to run Kubernetes on Amazon, it's a pretty good way of doing it. We had, Tectonic was in the supported category, but maybe not so much of a multi-cloud solution, and obviously OpenShift is evolving from that. There's a great distro called Typhoon, for those who don't know it. One of the employees at CoreOS basically said, I'm going to take the core pieces of Tectonic that are open source and build a fully packaged open source distro around that. So you can go get that, download it. It's really kind of free and community driven in the best sense of the words. Then I think we've seen a lot of great work with Rancher doing multi-cloud management, and then when you start to get into managed, you get the various cloud operators, managed services, and we've started to see, I think, one of the most interesting moves of last year was Google moving into a true multi-cloud approach, saying, sure, we have GKE, but if you want to run on other clouds, we have a control plane that'll allow you to do that as well. And I think NetApp as well, I saw them out in the sponsorship area. I think they've done a great job with the StackPoint cloud technology, really providing kind of a layer on top of Kubernetes that allows you to use multiple distros. And if you don't know what this means, the kind of the a bit of a screenshot here, and I have no affiliation with NetApp, so this is really just to illustrate my point of, what does it mean for a distro or a solution to be truly multi-cloud? I mean, this idea that your first step is, I'm going to choose, do I want to create a cluster that's EKS? Do I want to create an AKS cluster? Or do I want to build my own cluster in one of those cloud environments? Or do I want to deploy into VMware in my data center? This kind of next level of control, for me, is kind of where the distributions are going. And the simplicity of being able to pick any of these and then manage across essentially a fleet of clusters in the same way that Kubernetes enabled you to manage across a fleet of nodes. This is kind of where these technologies are going. So I'm pretty excited about these kind of developments. But really, this leads to the next question, which is, we can do it, but should we, right? This phrase multi-cloud tends to actually be quite polarizing. A lot of customers I talk to, they'll say something. In fact, we have a customer we're working with right now. We have a corporate policy. Everything we do is on Azure. I'm not interested in multi-cloud. You tell me how to get this up and running in AKS, and that's all I need to know. And that may be a fine, an absolutely fine strategy for some people. And they'll probably look at this and say, yeah, absolutely. Trying to go multi-cloud, if you go into N clouds, you're just exponentially increasing the level of complexity by N. So there's kind of this pivoting here into the second part of my talk, where I want to look at, are there reasons and can we see case studies where people are adopting multi-cloud and it's bringing value? And I'm going to talk a little bit about a customer that we have called PubNative. So they were founded in just 2014. So we think we're in a fast-growing space. They had 10x traffic growth in 2018. So this is essentially the technology platform that's serving up ads to your mobile phones. So really making the world a lot better. No value judgments. But no, there's a real strong growing business here. In just 5 years, they've expanded into 120 countries around the world. Really successful story, but all running in VMs in AWS, as a lot of startups do, just to get started. And they actually, so the technology here, if you're not familiar with it, so when you're viewing an application on your phone, you go to a page, there'll be a space for an ad. It'll go up to the server, and the server will fan out a request to a lot of back-end services. So the industry is actually split into supply side and demand side. So they're just on the supply side. They're bringing a request for an ad. They're then federated out to a lot of demand side platforms. And the bidders will bid a price for an ad. So if you think about how fast an ad appears on your phone, this all has to happen in a matter of milliseconds. Time is critical because if you're not responding fast, then you're just not going to get the ad opportunity. That's gone. So you've got hundreds of thousands of API requests per second going through this thing, and also quite a lot of traffic as well. And this was what they were finding with the architecture that they had was, number one, it wasn't super scalable. I mean, they had the business logic, they had the performance that they needed building in VMs in Amazon, but they didn't have the scalability, and particularly didn't have the cost ratios that they needed. So they really tracked how much they were spending per ad, and it was getting out of hand. And in fact, that 10x growth was, on the one hand, a positive. On the other, it was practically killing them because their costs had gone out of control at this point, and they had to put a brake on the growth of the whole business because the underlying technology platform couldn't take them forward. So this is when they came to us, and we started working with them on how can a multi-cloud solution work where they're going to optimize for different things on different clouds. And from a cost perspective, we came up with looking at a bare metal cloud option called Packet, which this is not their numbers. This is just using standard pricing. But you can see it's not just compute costs that were significant. In fact, for them, the actual numbers were the egress traffic was by far the biggest element in the price differential between the two platforms. So it's adding these up, they would get at least a 50% savings by moving across to these from AWS to Packet. But they didn't want to move everything because there were some services they were using in AWS that were quite valuable. There was a lot of redundancy that they had there. So they built a multi-cloud strategy which was based around identifying the best place for the best workload. And anything which was kind of a high value but not consuming a lot of compute resources, not consuming a lot of network, would stay in AWS. Anything where they were using specific services like S3, obviously, they're going to keep that there. And also pretty critically, and we've actually seen this, and I've seen people questioning whether this is a real thing, but absolutely bursting for demand spikes and for failover as well. If they've got an upgrade happening on one side, then being able to just fail over with global DNS from one to another, that's usage that they have in AWS. And then on the Packet side, they would have anything that was super egress intensive, so all of the traffic that's coming directly from the apps, anything that's compute intensive, and although for this specific application we didn't use it, one of the things that some other customers are doing is custom hardware, and with a bare metal provider, you can say, I want this specific piece of hardware, and they'll create it for you. So that was another consideration. But to make this all work, this is where we introduced Kubernetes into the picture, because it was the way that we could basically create a common computing platform and a way of scaling that we knew how to take forward and they could see was the path forward. And so Kubernetes was really an enabler for this project. I mean, I would say without Kubernetes, there is no way we could have made this happen. For me, that's really kind of the payback for a lot of the hard work that we put in at a technology level, seeing this kind of project take place. Now, it's not without its challenges, because when we're looking at a bare metal cloud, it really is bare metal. You essentially are getting machines, you're getting switches, but it's pretty complex to set up. There's no VPCs, no VNets, nothing like that. And all of those services that you're used to getting, like a cloud load balancer, security groups, network-based firewalls, host protection, and even just like basic storage services, EBS kind of things, none of those available in Packet. So we had to kind of think about how you build a Kubernetes distro or deployment into this environment. And one of the key things that wasn't available in Packet was a managed Kubernetes service. Every other cloud these days has a managed Kubernetes service. And I encourage you to read this. I mean, this is a great lesson in being focused, because Packet's decided what they want to do is provide essentially compute and networking, scalable globally, but that's it. And everything above that layer is your problem. So they've got a lot of customers asking them for it, but they're saying, no, we are going to stay focused. And so we had to work out, how do we build something that gives that kind of managed Kubernetes experience in this environment? So what do we have to start with? We had some APIs to be able to create machines, and to be able to create an IP address on a switch. You've got serial console access for when things really go bad and you have to get into the machine. And you don't have external storage, but you have some storage optimized server configs, and that's kind of it. So how do we kind of build a modern Kubernetes distro out of this? Well, the first problem is, how do we get traffic into the cluster? So most people are pretty comfortable these days with creating Kubernetes services, and there's this great type load balancer which advertises to an external load balancer and is how you bring traffic in. So does anyone want to guess what happens when you deploy this in Packet, say, or in a bare metal cloud of any sort? Nothing is the right answer. Absolutely nothing, not a sausage. Is that a British expression? Probably is. So if you look in the document, it says this is what it does, and it's all awesome, provided your cloud provider supports it. Well, it doesn't. There is no load balancer available in packets. So we actually used a project that came out of an engineer inside Google called MetalLB. Awesome project. Does what it says on the tin, load balancer for bare metal environments. So we used a combination of Contour for ingress, and then on each machine that's running Contour in the cluster, you run a MetalLB. It advertises the address of that ingress service up to the top of rack switch. You get ECMP, so equal cost multipath load balancing across the racks. For those who don't know, it's basically kind of a minimal kind of load balancing provided by the switch. And we got super performance out of this. No explicit load balancer, no software load balancer involved. And we're processing hundreds of thousands of API requests through this per second. So we're pretty happy with this. There are some downsides of ECMP. So you have to get into doing balancing of worker nodes across racks. So you do have to understand some of the physical things. And when you're using Calico, it doesn't necessarily work out of the box, but there's some workarounds for this. So we put all this together and we got it working. Talking of Calico, this was another great aspect of thinking about what happens in bare metal is you have no network protection essentially, so you have no security groups, etc. So Calico is known for networking and maybe doing network policy. People don't know it has this hidden superpower. I mean, I knew because obviously I came from the project, but it's very rarely known that Calico can also do host protection. So you can run it as an agent on servers, and it protects the host interfaces. So this gives you effectively a built-in firewall on every machine running in the cluster. No need for an external virtual firewall or anything like that. There were some things we had to enhance with it. So automatic creation as we scale up nodes of the object in the Calico API. And we're looking at things that we want to do in the future. So Calico's just added support for BPF, and so we want to use that capability to do this, get more out of it. On the storage front, I mentioned there's no external storage, but we have these storage optimized nodes. We run a project called OpenEBS, which effectively provides an EBS-like layer across all of these nodes. It's working well for some use cases. There's definitely, it's pretty early, and we certainly saw some performance issues with really high performance storage applications. And anything that was redundant, there's no point using the underlying redundancy. But there's a new engine that the OpenEBS folks are working on that's just come out called MayaStore. And so we're really looking forward to that as a new high performance engine there in OpenEBS. Next thing was cluster auto-scaling. This is something you can read about in the docs. Cluster auto-scaling scales up nodes automatically based on there being outstanding pod requests that can't be fulfilled, which is great, except this box in yellow is cloud-specific. And guess what? There was no implementation for Packet. So we worked with the Packet folks to implement a cluster auto-scaler. And I'm really pleased to say, as of Kubernetes 1.16, that's now been merged and is available. Next area, VPN. So we had to build a highly available multi-cloud VPN. We ran strong Swan as pods in Kubernetes. And this is one of the great things. Kubernetes provided us that automatically the resilience. If one of those pods goes down, Kubernetes will just make sure it gets restarted. So we're leveraging the AWS VPN service on their side, and Kubernetes providing the HA capabilities on the packet side. So this is pretty cool. So all of these learnings we've wrapped up. We've got a distro of our own, which we call Locomotive, which is built on Typhoon. So a lot of this, I mentioned Typhoon earlier. You might have been scratching your heads. Why is that on that slide? So we've actually derived Locomotive from Typhoon, 100% open source. We're working with a lot of folks in the community around this. And all of these, it works great on Packet. It works on AWS as well. But we're integrating all of these as components within this environment. Another aspect of this is we actually put our own Linux distro into this, which was called Flatcar, and it's based on CoreOS Container Linux. So we're basically taking Container Linux forward and creating modern kernels and supporting the latest hardware with that. So this is a really important part of how we've achieved this. I think just coming down to the bottom line here for the customer and for the end user, this whole project from beginning to end was 3 months to get them into production. But more importantly, there was a 3-month payback time. So the actual cost of implementing this, they paid back within the amount of time it took to actually deploy it, given those cost savings that I was talking about at the beginning and the scale of their business. So I think people are talking about looking economic recession, whatever, is that going to kill this whole space? I think when you see these kind of results, this is going to drive these migrations are going to be happening for many years to come because the underlying economics are just so compelling. And Bruno, who's director of engineering, who is responsible for the project, there's a longer quote. This is from him. He just says this was a no-brainer. In fact, I chatted with him. I had lunch with him a couple of weeks ago, and he said, "Yeah, I'm not going to KubeCon. I'm not interested in Kubernetes." Which is a really interesting kind of perspective, right? Is this big project? Kubernetes has been a big part of enabling this. But for him, it's just infrastructure. He's interested in the applications he can build in it, what he can do with it, big data analysis, all of that. He's not interested in Kubernetes, and I think that's kind of where we want to get to as an industry. Is this stuff becomes boring? We enable these cost savings. We enable these kind of projects. So we're pretty proud of what we together have done here, and as Dan said, we're standing on the shoulders of giants here. This is just putting together pieces that a massive community has worked to create. So talking of community, I'm going to just do one quick plug. If you are going to KubeCon in San Diego, we also organize a conference prior to KubeCon, which we call Rejects. So we proudly wear the label. There are a lot of folks out there who have their talks rejected from KubeCon. Actually, I think this KubeCon was the first one that I didn't have a talk rejected, and that's because it was the first one I hadn't submitted to. I'm learning. So do check it out. There's actually several of the other companies here that are involved in this and sponsoring it, and we'll love to see you there and see you in San Diego. And I'll see you around here. I'll be here all day as well. I'm looking forward to making at least 10 new friends. Thank you.